Hello, and thank you. I was trying to make this slide as dramatic as possible. So, and let's start. So I'm Ivan. I'm originally from Russia. I live for 10 years already in Serbia. These are two startups I was helping in the past years. I'm on Rails since 2006. I'm a small Ruby on Rails agency owner, and I used to work for GitLab as a fun fact. And those are two small projects, not completely finished, but you still might find them useful. So, and why I'm here? So, I'm here to play the role of this guy. So, I know that service objects is like a widely accepted pattern in the community, yet we're gonna question this. So the plan is the following. First of all, I'm gonna share one method which I kind of invented a few years ago. I call it OOP in pictures, and we're gonna use it later in the talk. And then we will see how developers, what developers talk about service objects in their articles, and what are the benefits, what they think service objects given them. And then we're gonna talk about roots of the concepts. We will analyze what guys like Martin Fowler, Eric Evans, and Robert Martin said about service objects, and try to get an idea from that. And we'll see how service objects look in serious big projects. I will show you some examples from GitLab repository. And in the end, I will show how I do it and how I think about it. And the last part, I think, is the most important. So, service object, this is like, I'm gonna be really bold now. Service object is a very strange, controversial, and harmful abstraction that doesn't make any sense, and which contradicts with main architectural principles. And it doesn't give you any benefits. And I would say in long term, because at the first place, it might look that it actually gives you benefits, but we will see that it actually doesn't. So, OOP in pictures. If you're interested, there's a whole presentation on it, like from my talk in RailsConf. There's a QR code, and it will be shown later if you will be interested as well. So, the fun part. This is the method I invented when I was teaching my students, and I was explaining object-oriented programming to them. And I really like drawing those little dudes, so I decided, why wouldn't I draw like classes as those little dudes? And then I decided, well, and I actually can draw hands, and the way you can interact with a class, with an object actually, you just shake one of their hands. So, and then I started developing this idea. So, how the rest of the ontology would look like. And I figured out that those hands, they can be actually like robo arms with fingers, and through those fingers, those methods can accept arguments, and obviously number of fingers represents number of arguments. And those arguments, they go into their brains, and those are instance variables, and later they can be reused in other methods. And to get a result of a function or a method, you open this hatch and you get the result. And private methods is a funny concept because those are still arms, but they are kind of internal ones. So no one can shake them from outside, but the guy still can use them. Exception looks like this. You still get the result, but from the different place. And maybe not the nice one. And with this, you can start seeing anti-patterns visually. So for example, like too many arguments, too many methods, too long methods, too many instance variables, too much conditional logic in the method, or too much of everything. So And another, and we were talking about objects for now, but what about classes? And I was not sure how to express it visually, and then I came up with the idea of kind of spawning platform that has a cartridge, and on this cartridge we have an instructions on what object to spawn. And we have this lever, we pull it, and the magic happens, and we get an object. And the fun part is that actually these two things, they have the same ontology. And essentially this lever is the same as hand, and it also can have fingers, apparently, and this is also just a method. So that's the story, and I use this method to analyze the talk of Sandy Metz and to represent how the complexity of a class was changed over time. And I find it really useful. So you don't have to analyze the code, you just see how much complexity have been added. So we're gonna use this method as well today. Okay, what is service object? And let's see what developers say. I analyzed like, I don't know, a dozen of articles and collected opinions of various developers. So they are crucial for enhancing like code efficiency and maintainability. They help you structure, improve structure, organization, and testability. They encapsulate business logic. They make your code more modular, easier to maintain, easier to test. Avoid code bloat and cluttering of the code. Keep your code clean and organized. Encapsulate business logic. Simplify development process. Make testing easier, etc., etc. They are single responsibility, and sometimes you also get a bit of criticism, like service objects are crappy and better solutions exist, but unfortunately the author doesn't say what are those alternatives. Okay, and yeah, this is a short summary of what they said, what developers saying. And what do they do? Let's see the quote from those articles. And first of all, we get this guy. What it does, it simply creates a book with some parameters passed to it, and we have a lot of boilerplate code, which essentially, which is essential there just to get the shape of a service object. But the useful code is very short here. So another one, validate discount code. So I'm not sure, like, maybe it could be a validation, maybe it could be just a method in a model. But yeah, for some reason it's also a service object. This one, here we also have a mutation, and a message, we send email to our user. So it looks like some kind of a business operation here. Another one, my favorite one. So, and this one here, another business operation, which consists of mutation. We update our trip with parameters, but also we go to external service, to Google Maps, and fetch distance and duration of the trip, and update trip with it as well. This one is a little bit longer, and there are a few more methods below. So it is authentication service. You don't have to read in detail what it does. We will explore it later in details. And the final one is a class called Tweet Creator, which basically a wrapper around Twitter API to create a tweet. And what do we see? What does this code do? We see some kind of validation, we see a calculation, we see a creation of an entity, we see mutation, business scenarios of two kinds, mutation plus notification, external service call plus mutation, and we see wrapper for external service. And to me, it is a little bit strange why this code is doing so many different things, and it is called the same, but let's continue. And if we try to come up with a definition at this point, the definition will be this. They just do some stuff. And I wanted to find some kind of more deep philosophical idea behind it. Like, is there one? And I decided to analyze what our fathers said about it. So first of all, what is so service about service objects? And to understand that, I decided to go through those famous books of these guys. And in his book, Patterns of Enterprise Architecture, Martin Fowler is saying that basically he doesn't mention the idea of service object. And the closest concept I found there is service layer. And they're going to be a visual representation of what I think they meant in order to kind of have the whole picture like visually. So first of all, there's an application and there's a domain logic and application logic, and service layer defines application boundary. Also, it sets available operations, so they are inside the service layer. And it would be fair to say that inside those operations, coordination of domain objects happen. And also, service layer controls transactions, and I think it's happening in the same place. And also, the same operations, they encapsulate the application business logic. And the final bit is that services in service layer by Martin Fowler, they coordinate responses. But the trick here is that Fowler suggests that services can be called either remotely or locally. So if our application is just a regular monolith and it's not kind of a microservice architecture, I would say we can ditch it. We don't need it. So, yeah. And Eric Evans in DDD, the closest concept to service object in his book is domain services. And the first thing he mentions is that they are stateless. So they just take some arguments, they do their stuff, and that's it. They are named for an activity rather than an entity. And they represent significant business domain processes and operations. And they are distinct from technical services. This is interesting. So he doesn't say what are those technical services. He's just saying that they are different. So, and those business operations, they may have side effects. And I treat it is that they actually should have side effects. It could be that there will be no side effects if some condition they are not met, but in principle there should be some. And Robert Martin, in his book Clean Code, he's saying that service should have well-defined interface. Honestly, I don't know what he meant, but I drew it. So anyway, it can be a single component or it can be composed of a several component. I drew it as well. And those components separated by architectural boundaries. And unfortunately, the context in which he mentions this is that, yeah, again, microservices and service-oriented architecture. So those are kind of, it's not really relevant to our like very low-key monolithic world, unfortunately. But he also mentions the importance of single responsibility principle. And I think it actually can be applied to us. So let's keep it there. Okay, so this is the message being sent to us by the fathers of complexity management. And kind of lots of rules. Let's try to kind of squeeze it. And I kind of squeezed it a bit. And then a bit more. And now we have crafted our service ruler. And with this ruler, we're gonna be measuring like the services we met. So domain services, they should be stateless. Well, actually, we will see it a few more times, so no need to read it. All right, let's try to analyze. And yeah, this one, it is not stateless. There's a constructor. There's some state being stored in the object. So it's named for an activity, not entity. No, we failed. For the rest, I would say yes, we have passed. It represents some business operation. It coordinates domain objects. It controls transaction. It complies with single responsibility principle, and it should have side effects, and there's no application logic. All right, another one. And this one fails miserably. So yeah, definitely not a domain service. This one, again, looks like another business operation we've got here, but doesn't really not sure if it complies with SRP, because actually it does two things. It does a mutation. It also calls some external service, so we need to think. Depends on how we look at it. Another one, again, fails miserably. Doesn't coordinate any domain object. Doesn't represent business operation, but it is stateful. Another business operation we've got here, again, doesn't comply with SRP because it does two things. It works with external service and does a mutation. And this one, another business operation we've got here, but we've got plenty of code here. So, and apparently it does a lot of things. And most of the developers that I ask, they think about such code that actually it is, this thing is single responsibility. Like the whole thing is about user authentication. Therefore, there's a single responsibility of authenticating users. And nope, unfortunately, no. But this is not what Martin Fowler meant. He meant that there should be only single reason to change a unit of code. And here we have plenty of reasons. All right, the final one, not a domain service as well, works with external external system. It complies with SRP. It has side effects, but for the rest, no, it's not a domain service according to the fathers. So what do we see? This code, which everyone calls service object, they just do different kind of stuff. Some of them are definitely not domain services. None of them match all the requirements, yet developers name them the same. They put them in the same bucket, and this is a bit strange. Did we achieve what we wanted? Maintainability, avoid code bloat. I'm kind of not sure. Like, it's not yet clear. Single responsibility, sometimes we've got it, sometimes not. Like, and we see that the bigger our service object gets, like the less single responsibility we have. More modular, not sure, again. Encapsulates business logic, yes, for sure. I think the whole thing is for the sake of an encapsulation, but we could encapsulate logic in methods as well. So not sure what's the benefit here. And easier to test, again, with small pieces of code, yes, easier. Like when it gets bigger, I'm not so sure. And about structure and organization, I would say the same. So let's continue. What is so object about service objects? And in other words, is there a reason why they are shaped like objects? So 3 pillars of object-oriented programming: encapsulation, inheritance, polymorphism. Encapsulation, we see a lot. Inheritance, I would say it's a really bad idea to start using inheritance here. And polymorphism, I couldn't come up with a reason to use it here. So not so many reasons to use OOP here, like concepts of OOP. And 3 more ideas. Is there a reason, like, is there a state which needs to be managed? in the story. Is there a life cycle of an object we are about to create? Can we imagine a situation where we need multiple instances of a class at the same place? And the answer is no. So pretty much nothing tells us that we should be using OOP here. And what is service object? Let's try to answer this question again. It looks like it's just a technical trick with no huge idea behind it. In the sake of, and I was really trying hard to like find this reason, and the only one I found, the two I found, like moving code from controller. And remember, the whole thing started like we're having fed models, fed controllers. Let's solve this problem with services, and now we have what? Fed services. Perfect. And testing it separately from controller. Yes, I would say it's a good reason. But later we will see that actually services, they take more and more, like in many cases, they take a lot of responsibilities from controllers. So you are kind of testing it separately from controllers, but still you have stolen most of the functionality from controllers. So it's not a huge win, actually. Okay, let's see how serious guys are doing it. Like they must have like invest it in it better, and they should really should have been understand something. And the good thing is that yes, the code is open source, and we can see in the dynamics how the things have changed over time. And I will be showing just, I don't know, random service objects I found there. And some of them, they are not too big. Again, there is a state, and those are 3 hairs. Those are they are representing author readers. So only 2 arms, one public, one internal, and the constructor doesn't look scary. I see it does something with caching. I would say caching is an application level logic, but okay, fine, whatever. Another one, 2 internal methods, one public, kind of okay. This one already is a bit bigger, 5 private methods. And what we see here, we see that one service calls another service. And also, it is inherited from a thing called base service. And in the base service, there is a small include, which includes this thing. So it looks that like this thing is quite complex. And it looks like this thing is like, they have to invent the whole framework to manage this kind of complexity. And still it looks complex. So let's continue. This guy, I had to record a GIF just to show you like the whole thing. So it has about 200 lines of code. And but what is interesting is at the beginning, it was also a very small and compact and nice service object with only 2 private methods. But over time, it grew and grew, and it turned into this monster. So what we see that with this idea of service objects, the complexity grows inward. And that's a bad sign. What we see? We see that service objects, they proactively stealing controllers' responsibilities. They kind of preparing responses. They work with sessions, etc., etc. We see that we see a mix of application logic with domain logic inside those service objects. And the code, and this is a really important part, the code is doing different types of work, and but I would say those service objects, they are doing different types of work, but we still put them in the same bucket and call them the same. And inside we see lots of low-level code also doing different types of work. And if we represent it visually, it will look something like this. So if those colors represent different types of work, for example, red is interaction with external system, green is mutation, yellow is, I know, business rules. So the picture looks like this, and we put this shit into the same bucket. So, and these are different kinds of work these guys are doing. So, and yeah, I let it sink for a while. So, what we see, few more observations from what we've seen. We've seen once that there's a call chain of services, and if we allow one service to call another, it basically means that this service that we've called, it can also call another service, and this can call another, and another, and another, and we even can get a circular dependency, and I've seen it in the wild, and that it doesn't look nice. So we see inheritance. We don't like it as well. We see that over time complexity grows inward. Doesn't look nice. We see the service layer becomes responsible for everything. And effectively, we have killed ideas of layered architecture, ideas of modularity, and ideas of single responsibility principle. Doesn't look nice. So, the definition of the curse. There's no reason for services to be shaped as objects. They doesn't match with what Father said. Developers do not actually achieve what they wanted to achieve, and practice actually opposes the ideas of layered architecture, modularity, and SRP. Again, this picture. And what if instead of putting different code into building blocks of the same shape, we would start finding the right places and the right shapes for different kinds of code in our application? And what if we could find a shelf, find its own shelf for different types of work in our application? What if there would be a shelf for business operation? There will be a shelf for business rules. There will be a shelf for complex mutations, a shelf for interaction with external systems, and like the place to work with data preparation, validations, etc., etc. And I really like this quote that throughout our history, it has always been standardization of components that has enabled creations of greater complexity. And I think this standardization is actually achievable, and I will show you how I achieve it. So how do I do it? And how do I think about it? Let's take this guy. I promised we will work with him a little bit more. So first thing I'm doing when I'm seeing such code is that I'm trying to see what types of work this code is doing. And short note that I'm completely fine with long methods, as long they are doing like the same type of work and it is of the same level of abstraction. I think that most of the code we write on the daily basis, those are just procedures. And if we have a long business operation, it's fine for it to look as a long method. So, okay, those are kinds of work this code is doing. So we see some controller level logic of working with session and preparing responses. we see some rendering, we see mutations, we see business rules, and we see one call to one interaction with external service. So yeah, let's find that own shelf for every type of fork. And some shelves we do have already. And the first shelf would be a model. And we can extract those business rules where we ask a user if account logged or if it's a first login from new IP. So yeah, we can just put it in the model. It looks like there's already a place for it. And for low-level details of complex mutation, we will put it into its own mutator layer. And mutators, they are just procedures again. And essentially, this is a method to avoid callbacks completely. It will be just a procedure of your model creation, and in complex cases, creating one entity. During creation of one entity, you actually need to create and fill in some special way plenty of associations. So, and I would just put this in this in a procedure, and this will guarantee you that in your code base there will no longer be half-baked entities. Like we already started creating some object, but some associations are not yet created. This method actually helps you avoid this problem. So yeah, I would just create a folder, mutators. I would create a module or a class, doesn't matter, because it is just a container for functions. And I would just put those two functions there. They will just do their job. And I will just call them from a service. So, and domain services, they are just business operations. They do represent business operations. And it means like we have a business operation, we have one service. And it is also just a procedure, but the code there should be of a high level of abstraction. And this is how it looks like. So remember, we have moved mutation details on a mutator level. We have moved business rules to the model. So now our code looks actually much more high-level-ish, so to say. I put interaction with the mailer like this. I don't think it makes sense to wrap it into something because it is obvious what it's doing. If it would be a more complex iteration, it would go to a separate bucket as well. So, and of course, we want to keep application logic outside of services. For example, permissions check and data preparation, I would also do outside of services and only call this service with valid params. I know that nobody actually does it, but you will see that actually it does a lot of sense. Makes a lot of sense. Yeah, and this is how a controller would look like. So we find this user and we don't execute service until we're sure everything is fine. And we prepare responses here on a controller level. We work with session as well here. So we let controller to take care about application logic. And here's what we've got. So on the bottom, we have our model. Then we have a mutator. Then we have a user service. And then we have a controller. And this is what we had in the beginning. And this is what we've got. So instead of having single class, which over time will become bigger and bigger, we have found places to put this functionality to, and we have built much smaller building blocks. And over time, we just get more of those simple building blocks instead of having like a bigger complex ones. yeah, this is what we've got. And surprisingly, this thing is stateless. It is just a function. It is named for an activity, not entity, so it's called authenticate. It represents business operation. It coordinates the main objects. It controls transactions via calling mutators. It complies with single responsibility principle because it represents all the business logic on a high level of abstraction. It has side effects, obviously. Yeah, and the code is of same level of abstraction. What we've got here is modularity. What we've got here is layered architecture. What we've got here is single responsibility principle because every piece of this code has only one reason to change. Yeah. And yeah, this thing is much more easier to test. I would still not test it. I would still test only controller, but that's the separate story. And if I would, like this picture I drew just to highlight the idea that on those different layers, we have code of a different abstraction. And these guys are doing different kinds of work because a lot of developers, they just do, all right, I have a bit of too much code here, I just copy it there, I just copy it there, I just copy it there. Instead, I insist that you should think where this code belongs. Find this place in the Rails, in the tooling of Rails, or invent your own layer and put it there. That would work just fine. So we did a little, like very little tweaking to what Rails gives us here, and we've returned it to ideas of layered architecture. And let's quickly refactor all those service objects from the beginning of the talk. So this guy, it is just a mutator, right? So if the creation logic gets more complex, the mutator will grow, but the service we will don't have to change. This guy, I would put it into a model, into the model. It would be just a method legitimate and the finder method. This guy, yeah, this is a service. This is valid business operation. It can be a service. It can be put into service. There's no reason for it to be stateful, so it's just a function. This guy, just a method in the model, obviously. This one, this is interesting because I think that we've got more code here than originally, but what we've got is that we separated this manager, which does interaction with external service. And our service, yes, it has more code, but the code is just simple. It's just simple procedure that, like line by line, you clearly understand what's happening, and yeah, you are not mixing two things in one. All right, and this guy, it will be just. I call them managers, like the building blocks that are interacting with external systems. And you can see that I kind of reverted it because originally, like the author passed message into constructor and instantiated REST client in the method call, but actually it should be the opposite. So that's it actually. And do you still think that service object was a good idea? I would really love to get argumented kind of ideas. And if you still think that I'm wrong, I would love to discuss that. And I hope that you will get enough of things to discuss during the lunch. So if we have any time for questions, I would love to answer them.
Boom, roasted. That's what I wanted to say.
Thank you very much for your talk. I love the examples where you simplify the service objects, but I wanted to ask about the inverse, which is what about over-engineering? Because GitLab is a quite a sophisticated application, and it has a very complex even login logic because of security concerns, I guess. And most people will probably never work on an app even close to that big. So don't you think there is a risk that they will just invent layers for the sake of inventing layers and add classes for sake of adding classes, where a simpler approach might be just enough?
I insist that this approach is simpler because we haven't changed much to what Rails gives us. We just like service layer we do already have. The only thing that we have introduced so far is mutator level. And also in practice, you don't have to add like, if there would be a simple user creation with one line of code, I wouldn't wrap it into mutator and wrap it into service and call this all like the whole hamburger. I would just keep it. Huh? It was already a bit long, so but it could be, yes, it could be. So it's not like those examples, like if I would be refactoring them tomorrow, the code would look a little bit different. So, but yeah, it's not the real problem actually. So it could go into controller, and with time you extract it to mutator. That's how I do it basically.
So one of your arguments against service objects is that service objects are not objects and they are not object-oriented programming. However, in your approach, you go totally in the direction opposite of object-oriented. And my question is like, when would you use object-oriented paradigm as opposed to procedural programming, which is, I assume, what you advocate?
Well, I guess, when you develop some code, when you extend your framework, when you develop in some kind of libraries, you will need object-oriented. You might need object-oriented approach, but yes, most of the code which we are writing on the daily basis, it should be just procedures. It should be as simple as possible. And when we come up with the concepts like monads, etc., dependency injection, we are not doing good. This kind of shit, it's good like for internals, for libraries, for gems, but in the regular code, it shouldn't be there.
Thank you for your talk. You said that you should use different tools for different approaches, and I'm curious, did you use interactors? And if yes, for which cases did you use it?
Interactors, they just add even more boilerplate and even more bullshit to the idea of service objects. So I don't recommend to use it at all. If you can simply convert it into functions and it will work just fine. Like basically you will decrease amount of code like significantly if you just put it into functions, into regular functions.
Hey, thank you for the talk. Do you have any large race application where this pattern has been applied?
I've seen some, and the two projects I've been working on, I've shown, I was practicing this, and I would say in reality it doesn't always look that nice. There always gonna be some amount of dirty solutions, and sometimes it's justified because sometimes it's just faster and more pragmatic to do it in a in that kind of way. The only thing you have to take care about is that this piece of code ideally shouldn't be replicated. So it should be isolated, then it's fine. So I can actually, yes, I will probably share on Twitter like the repository where you can see this approach in practice. I should have been added it here. So yeah, I will show it. I will share it.
Great, thank you. And one more question: do you find this to be an extension to to the patterns you wrote in your Painless Race book, like the shapes, for example?
The shapes, the shape. I don't think it was a good. It was a nice name. Essentially, it's just a form, and this is kind of thing. This is the evolution of what I wrote in my book, and I need to basically rewrite it. And yeah, but forms is a very unfortunately I wasn't able to add it to my talk because working with forms is very interesting concept as well. I will probably do another talk about it. Yeah.
Thank you.
All right. Thanks, Ivan, for curing this disease. Ladies and gentlemen, Ivan Nemytchenko.